Okay, this video is about approximating arc length and sector area. Okay, so because we're now going to be approximating, what that means is in these formulas, we're actually going to type in or use pi as an approximated value in order to give the arc length or the area of a sector of a circle, and we're going to round to the nearest tenth, I think, in most cases. All right, so let's review the two formulas first. Arc length. So remember, we have an arc of a circle that is defined by having two radii that form a central angle, and thus creating this arc length right here, that fractional part of the rim. So here's what I know. I know that arc length is equal to theta over 360. And remember, we take the radius times 2 to get diameter times pi. So we've already done problems like this. The difference is now we're going to approximate to the nearest tenth what the actual length is. Okay? The second formula that we've been working on is the area of a sector. So remember, a sector, again, is created by a central angle in the case that we're looking at. Okay? And this would be finding the area of all this region, kind of the wedge, if you will, or the piece of the pizza, as we've said before. All right, so the area of a sector is, again, theta over 360. There's our fractional part of the radius squared times pi. And again, we've already done work with this, so none of these formulas should be new to you. But what we're trying to do now is approximate it to the nearest tenth. So we're going to be typing in pi into our equations. So let's take a look at some examples. The first one here. Notice in the directions, you got to pay attention. It says find the length of each arc. That's telling me they want me to find arc length. I know that arc length, I need the theta, got it, and I need the diameter. I don't have it. But I know the diameter is 2 times 6, or 12. So there's the second piece of my puzzle. All right? I'm going to take theta over 360, or 225 over 360, times the diameter, 12, times pi. Now, when I look at all these numbers, remember, these are all really divided by 1 when we write them. And what I want to do here is make my work as simple as possible by using, or through the use of the calculator. Okay? So I'm going to take my calculator here. I'm going to multiply 225 times 12 times pi. Notice I'm not using 3.14 or anything like that. Okay? And I get some decimal. Again, I am not rounding. I'm going to take that value and divide it by 360. I get that answer. Now I'm going to round. And I would have an arc length here of 23 rounded to the nearest tenth would be 23.6. So I know that my arc length is 23.6, and I need to label it inches. So remember, arc length, because it's part of a circumference, our units are going to be just the unit. Okay? All right, second problem over here. I've got theta, 90. I've got a radius. So I need to first find the diameter, which would be 18 times 2, or 36. I'm going to use this information to write the arc length formula out, which says that arc length is theta over 360 times 36, the diameter, times pi. And again, I don't have to worry about simplifying on these problems because the calculator is going to do all the work because I'm approximating. All right, so if I take 90 times 36 times pi, get that answer, divide that by 360, and round to the nearest tenth. 28.3 would be my arc length, and that's in yards. Okay? The second kind of problems that we're going to have here are the area of a sector. So again, I have to remember that formula. It's theta over 360 times r squared pi. But now they want me to round my answers to the nearest tenth, which is telling me use the pi button on the calculator. All right. So to find area of a sector, I need to know theta and the radius. Got them both. All right. So I know that the area of the sector will be theta over 360 times r squared. I'm going to go ahead and square it. So that would be 169 times pi. And again, remember, what's that 169? That's 13 being squared. Okay? All right. I grab my calculator. I've got 75 times 169 times pi. All right? And I'm going to divide that by 360. And that gives me, rounded to the nearest tenth, 110.6. So the area is 110.6. Now we need to label it yards squared. Remember, area is always units squared. All right, so the area of this one, I need theta, 240. I need r, 16, and I got to square that. So I'm going to go ahead here and say, what is r squared? Well, that would be 16 squared, and 16 squared would be what? Hopefully you guys know that's 256. If not, I can use a calculator for that. But I figured out everything I was going to need before I went to the formula. So now I'm going to find the area of the sector. And the area of the sector is going to be 240 over 360 times 256. That's my r squared times pi. I'm going to grab my handy dandy calculator. I have 240 times 256 times pi. I get that answer, and I divide that by 360, and that round to the nearest tenth will be 536.2. So the area is 536.2. Label it accordingly. That would be kilometers squared. All right, and that's how we approximate both the arc length and the area of a sector. Let me know if you have any questions. I'm happy to help.